Hello, welcome to the video. We are going to start today with a warm-up, and I'm going to take you back to Algebra 1 and ask you to factor each of these. So go ahead and pause the video and try to factor each of these expressions. Okay, and that is a correct factorization. The new part is some prep for section 5.3. Some of you will love this. Some of you will be a little uncomfortable and might need to do some more practice with the topic, or ask me for extra practice or schedule some office hours. I don't expect you to master this today, but if you find that you're like really struggling, then you want to contact me. Don't wait to ask for extra help if you need it. What we're going to be doing is factoring trig expressions. We did this once before in class. Okay, and some of you did that on the most recent quiz as well. Let's go ahead and factor. So here's what I'm talking about. If we have cosine of x times tangent of x minus cosine of x, this can be factored. And it looks really frightening. It looks completely different than what we were just working on, but it really has the same structure. What's making it scary is cosine and tangent. So what I like to do is I like to look at this as the first thing and something different, and then this is the same as the first thing. It sounds kind of wordy and weird, but I think you're going to find it works. So instead of cosine, because cosine is kind of freaking me out, I'm going to just put x to take the place. And then tangent is something different, so I can't call that x, so I'll call it y. And then there's a minus sign. And then cosine, should I call that z? Is that something new, or does that match something we had before? It matches something we had before that I used x to take the place of. So basically, I've just kind of replaced cosine with x and replaced tangent with y. And by doing that, I can look over here at the expression that's not scary, that doesn't have any trig in it. This type of factoring is just GCF factoring. So if you factor an x to the front, you're going to be left with y minus 1 in the parentheses. So using that same idea, if you look over here, hopefully you'll see it's the same structure. Just like this, these two terms had x in common, these two terms have cosine in common. So I'm going to put cosine out front. And then I put parentheses. And then how did I figure out how to get the y minus 1? Well, I took this first term and divided by x. So if I take this first term and divide by cosine, I'll be left with tangent. And then think again, how did we get the minus 1 over here? We took this and we divided it by x. That's how we got the minus 1. So what I'm going to do over here is I'm going to think of cosine x divided by this GCF. Cosine divided by cosine is 1. And it's still kind of frightening. You probably still feel uneasy with it. So what you want to do is you want to check your answer before you go to the next one. To check your answer, you don't have to write the check, but just go ahead and distribute. So if you take that cosine and distribute it into the parentheses, you'll have cosine times tangent. Those can't be combined, so they just go next to each other, minus cosine. And like I said, some people kind of immediately actually kind of like this topic, and some people are going to want a little more practice. All right, and it can help you out with that. Can always give you extra practice problems, or we can set up office hours if you find you're really struggling. All right, there's our first one. Let me move the paper down so we can take a look at number 2. For number 2, we're going to factor tangent squared minus sine squared. So taking a look at this example, this has 2 terms. Think back to the warm-up. When we have 2 terms, we might want to look for a difference of 2 squares. It could be GCF, but there's no GCF here, so we're going to look at difference of 2 squares. So the structure of this, again, instead of looking at tangent squared and sine squared, let's think of it as something squared. I'm going to call that x squared. And then let's think of it as something else squared, minus something different squared. So the structure of this tangent squared minus sine squared is the same as the structure of x squared minus y squared. So let's leave the scary trig expression for a minute. Let's go over here and factor this difference of 2 squares. To factor a difference of 2 squares, we make 2 sets of parentheses. We take the square root of the first term to start both, square root of the second term to end both, make one factor a plus, make one factor a difference, a minus. If you FOIL that, it checks out, you're good to go. And now we're going to apply that over here to tangent squared minus sine squared. So think about what we did. We made two sets of parentheses. We took the square root of the first term, that's tangent, and pause for a minute. Guys, if we do first times first, we get tangent squared. So even though we're uncomfortable, it's actually looking kind of good so far. All right. Then we take this square root of the second term, which is going to be sine of x. And don't forget those x's. You do need those in there. And then think about how we got the SIGNs. We just made one a plus and made one a minus. That is a correct factorization. If you're not sure, you can check it. You don't have to show the check. But if you FOIL, you'll have tangent times tangent. That's tangent squared. The outers will be minus tangent times sine. The inners will be plus sine times tangent. And last times last will be minus sine squared. These two terms cancel because they're exact opposites. If you don't see that, you can always use the commutative property to flip-flop those two factors. Okay, so tangent times sine, you have a minus in front. So negative tangent times sine and positive tangent times sine are going to cancel out. And sure enough, you're left with tan squared minus sine squared, which is exactly what we started with. So there's your factorization. Okay, we got two more to go, as you might imagine, because if you look back to the warm-up, you can see I'm kind of following that. The next one we're going to do is 2 times secant squared plus 3 times secant plus 1. All right, this one has 3 terms. The structure of this, well, there's a 2, and then there's a trig function squared. So I'm going to replace that with x squared just to look at the structure, or the format, if you like. Sometimes I call it the format. And then there's a plus, and then there's a 3. And then think here, secant. Should I use a different letter for that, or should I use the same letter I had before? Same letter. That's the same trig function. I didn't change trig function, so I'm going to use the same letter. I'm just not going to have the squared. And then I have a plus, and then I have 1. So some of you will find writing out the structure unnecessary because once you're comfortable, you're kind of comfortable actually, believe it or not, factoring these trig expressions. But some of you, for the entire unit, will want to write out the structure, and that's fine as well. All right. I kind of go back and forth. Sometimes I can just factor these trig expressions. Sometimes I like to write it out with x's instead. All right. So to factor this, we are going to put 2x and 1x because the only way to factor 2x squared is 2x and 1x. And then 1, good news, it has to be 1 and 1. And then even better news, if you look at the pluses and minuses, this is plus, this is plus. That means I've left no room for negatives here. So the factorization is 2x plus 1 times x plus 1. And if you check that by foiling, it works out. So using that same idea over here, we're going to make 2 sets of parentheses. The first term, to factor it, the only way to factor 2 secant squared with a secant in each set of parentheses, that's what we want, is a 2 secant x times secant x. And pause for a moment. If you multiply those together, sure enough, it's 2 secant squared. All right, and then over here, we have a 1. Oh, I forgot to say, because this is, of course, the ax squared plus cx, bx plus c. That's the type of factoring that this is. You recognize it, I say of course, because you recognize it when you're over here looking at it with just x's. It looks really weird with secants, all right? But that's the type of factoring we're doing. So here's where I was. We were looking to see how we can factor the plus 1. And the only way to factor plus 1 is with 1 and 1. Every term in this expression is positive. There's no negatives anywhere. So we don't even have to do any figuring out of that. And this is our factorization. If you're uncomfortable or you want to just be sure, you check it by foiling. You don't have to write out the check. If you do first times first, you have 2 secant squared. The outers, 2 secant times 1 is just plus 2 secant. Don't forget the x there. It is important. The inners will be plus secant. And then last times last is plus 1. If you combine your like terms, 2 secant squared doesn't have any like terms because there's no other secant squareds. But 2 secant x and 1 secant x make 3 secant x. And then you have a plus 1 at the end. And that matches what we started with. So we have a correct factorization. All right, one more to go. I bet you can guess how many terms it's going to have. because the last one in the warm-up, remember the warm-up was factoring by grouping. So that's what we're going to be doing here. Yes, with trig expressions. We are going to factor by grouping with trig expressions. So here's the one I made up for us. Okay. And here we go. Sometimes the eraser erases, and then when I switch back to the pen, it's still there. Okay, there. All right, teacher problems, don't worry about it. Okay, so here we have 4 terms. So 4 terms screams out to me factor by grouping. All right, but cotangents are scary. Oh, by the way, if anyone can just factor this with the cotangents, that's wonderful. I'd be surprised if you can do that now, but I won't be surprised if some of you are doing that tomorrow without writing out the x's, all right, without writing out the structure. Okay, so let's write out the structure because cotangent's scary. We start off with something cubed. I'm going to replace cotangent with x, so just something cubed. Then I have a plus, then I have a 3. Then I have the same something squared. So I don't want to introduce a new variable because it's still cotangent again. Then I have a plus, then I have a 2. And then I have cotangent again. So I'm going to use x over here in the structure. And then plus 6 for a constant. All right, to factor by grouping, we pair the first 2 terms. We find the GCF of the first 2 terms. We write it out front. We put parentheses. To find out what goes in the parentheses, we divide each term by x squared. So if you divide this term by x squared, you get x to the first. If you divide this term by x squared, you're left with plus 3. Then you put whatever sign is here, you actually drop down. Little trick from Algebra 1. So I'm going to bring down that plus. And then your GCF here is 2. Then you make parentheses, and then you find out what goes in the parentheses. To find out what goes in the parentheses, you divide the 2x by the little GCF there. 2x divided by 2 is x. To end the parentheses there, to end that binomial, we're going to divide 6 by the GCF of 2, and that leaves us with 3. And we're looking good because remember, if you are factoring by grouping, you want that repeated expression. So the final step here is to make 2 sets of parentheses. The first set of parentheses has x squared plus 2. The second set of parentheses has x plus 3. If you FOIL that to check, it works out. So we are ready to apply this skill to trig expressions. All right. So looking at the first 2 sets of parentheses and the first 2 terms and the second 2 terms, the little GCF here, instead of x squared, it's cotangent squared. Then I made parentheses. To find out what goes in the parentheses, I take the first term and I divide it by the little GCF there. That's going to leave me with regular cotangent, cotangent to the first, cotangent with no exponent. Then we're going to get the next term in the parentheses. Trying to erase the highlighter. Then we're going to get the next term in the parentheses by dividing this by the cotangent squared. That's going to leave us with plus 3. Okay, and you're very kind of uncomfortable with that step. So if you pause right here for a moment, what you can do is you can check by multiplying this back together. So if you multiply cotangent squared times cotangent, you get cotangent cubed. And cotangent squared times 3 is 3 cotangent squared. So even though it's uncomfortable, you can check at this stage by multiplying back together. Okay, then we go to our second pairing of terms. The little GCF there is 2. Then we make parentheses. To find out what goes in the parentheses, we divide this term by 2, leaving us with cotangent. Then we divide this term by 2, leaving us with plus 3. We have the matching expression that we're happy to see. So for our final answer, just like we did over here, we make 2 sets of parentheses. The first set of parentheses uses the 2 little numbers out front, the 2 little mini GCFs is what I call them. So cotangent squared plus 2. And then the repeated expression goes in the second set of parentheses. And last, we can check by FOILing. Okay, when you guys are doing this with X's and Y's, you probably don't check anymore, you just check mental math. But since this is, I meant to write cotangent, not cosine there. Since this is new and looks kind of weird, it's a good idea to actually do the check. So did I really just put back cosine? Okay. There we go. First times first. Cotangent squared times cotangent is cotangent cubed. The outers will be 3 cotangent squared. The inners will be 2 cotangent x. And last times last will be 6. Holy cow, that matches what we started with. We did it. All right, we'll kick things off tomorrow with a little more on this topic, and we will be using this skill later on in section 5.3. Thanks for watching.